Here, I have been asked to use the 5-step approach to graph the following polynomial equation. I've also been instructed not to use the calculator except to determine any kind of relative max or mins. So our first step is to determine the end behavior. The end behavior is determined by the leading term of my polynomial. In this case, my leading term is negative x cubed. We see that we have an odd exponent and we have a negative in front of it, and so the ends would go opposite directions. Because of the negative, the left-hand side would go up, the right-hand side would go down. The second thing we are asked to determine is the maximum number of zeros and the maximum number of turning points. The maximum number of zeros is always determined by the highest power in the polynomial, so that would be 3. The maximum number of turning points, which is the same as the maximum number of relative max and mins, is always 1 less than your actual degree, and so in this case it would end up being 2. Okay, step 3 is to find my y-intercept. To find the y-intercept, I will let x be 0, and then I will substitute 0 in everywhere there was an x in my function. So f of 0 equals negative 0 cubed plus 2 times 0 squared plus 4 times 0, and then minus 8. When I simplify, I would get just simply negative 8. Always make sure to write your y-intercept as an ordered pair. I plugged in an x of 0. I got out a y of negative 8. Box that in. That's something that I will want to graph later on. As my fourth step, I want to find my zeros, or my x-intercepts. So here what I will do is take my original function, and in place of f of x, I will substitute a 0 and then solve for x. So I would have 0 equals negative x cubed plus 2x squared plus 4x minus 8. This problem is one that I'm going to need to factor, and because there are 4 terms on the right hand side, I can try factor by grouping. I will group the first 2 terms together. You will always put a plus in between the first and second groups. Group the last 2 terms together, and then you want to try to factor something out of each of these groups. Out of the first group, we notice that we have a negative term first, and we also notice that we have an x squared in common. So we're actually going to factor out negative x squared. That would leave us with an x minus 2. Out of the second group, I could factor out a 4. So I'm going to factor out a positive 4. That would leave me with x minus 2. My general goal in factor by grouping is to make sure these 2 factors match. If they do, I write that factor once, and then I multiply by whatever I have left over. So in this case, negative x squared plus 4. Now, notice that this term has a negative in front of its x value. I'm actually going to factor a negative 1 only out of that one group, but I'm going to stick it at the front of my factors so I don't lose it. So I'll take a negative 1 out. I'm not taking it out of the first group, but I'm taking it out of the second group. So the signs in that second group are going to change. So it would become x squared minus 4. Now doing that, it makes it easier for me to factor that second group. The x minus 2 is not factorable, but the x squared minus 4 is difference of squares. So x plus 2, x minus 2. When you get to this point and have everything factored, if there are any factors that repeat, make sure to write them in exponential form. So I have an x minus 2 and an x minus 2. I need to rewrite that as x minus 2 squared. And then I have an x plus 2. That would be to the understood first power. The reason I do that is now when I'm finding the zeros, so for my zeros, the first one would be obtained by setting the x minus 2 equal to 0. Well, if x minus 2 is a factor, then I know x equals 2 is a 0, and I also know its multiplicity is 2. Because the multiplicity is even, I know that I would turn at that particular x value. Having x plus 2 as a factor means that x equals negative 2 would be a 0. It has a multiplicity of 1. Because the multiplicity is odd, I know my graph would go right through that point. However, to be able to graph this eventually, I would want to write these zeros as x-intercepts. So this one would be 2, 0, and this one would be negative 2, 0. Notice that I didn't do anything with the negative 1 that I had originally at the front of my factors. It doesn't contain an x, so I don't have to use it to find zeros. Alright, from here we're on to our final and last step, and that is to graph it. So step number 5, graph. The first thing that I want to do is actually plot any points that I have found. I've found these 2 points, and then I've also found up at the top a y-intercept. So I want to plot those 3 points to begin with. The y-intercept was 0, negative 8, so I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8. Go ahead and plot a point there. The x-intercept was 2, 0, so I'll go over 1, 2, plot a point there, and then to the left, 2, plot a point there. Now, knowing something about my end behavior, I know that the left-hand side of this particular graph goes up, and I know that from way back at the front when I said this is my end behavior. So I know the left side goes up, right side goes down. So going back down, I would have to come from here, and when I get to that 0, look to see what happens at that 0. That 0 is negative 2, 0, and notice that I'm supposed to go right through that 0. Okay, now I know that the right hand side is going down, so I know that I would come to that particular point from below. That 0 is 2, 0. Notice that I'm supposed to turn around. Okay, now I also know I'm supposed to go through this y-intercept of 0, negative 8, but I don't necessarily know if my minimum is going to occur on the left side of my y-axis or on the right side of my y-axis. So at this point, I'm going to need to go to the calculator to determine where my minimum value is going to be. Notice that I actually already know my maximum value. Here, this is a relative max, and I know that because not only is it a relative max, it's a 0, and it's a place where my graph turns around. Okay, let's go to the graphing calculator. So I'm going to want to enter my original function, so let me scroll back up to that. So we want to plug this into y1. So we'd have negative x raised to the third plus 2x squared, and then plus 4x minus 8. And then we're going to try a standard window. We know the y-intercept is negative 8, so the y-intercept will fit, but we don't necessarily know that the standard window will fit all of my graph. Let's just check and see. Okay, it gets close. It looks like it fits the minimum. We're a little bit far down. We may have trouble actually finding that. Let's go ahead and set the window. Let's go down to the y minimums and make that just a little bit smaller. Let's use negative 20. So set the y minimum at negative 20 and then graph, and I think this will make it a little bit easier for us to find our minimum value. It kind of centers it in the graph. Okay, press the second trace. We want to specifically find the minimum. Press enter. Go to the left of that minimum. Press enter. Go to the right of that minimum. Press enter, and then when it asks for a guess, press enter again. And here, if we round to 1 decimal place, we see we get negative 0.7 and negative 9.5. So let's go ahead and label that. Also notice what happened was that that minimum is achieved on the left-hand side of our y-axis. And that's what we originally did not know. So our graph is going to go through that y-intercept. Notice that it goes a little bit down before it curves back and comes back up. let's label that point, negative 0.7 and negative 9.5. What I would do is I would go ahead and extend this on down and indicate for me what you set the window to. This was 10, this was negative 10, this was positive 10, but this was negative 20, so that we could visually see that relative minimum a little bit easier.